Okay, so this section 7.1 is estimating a population proportion. So we're going to get a sample from a population and use the sample to estimate, you know, characteristic of the population. So today we'll talk about how to estimate population proportion. So point estimate, right? So what is the best value to estimate the population proportion? You get a sample, the sample proportion is the best estimator for the population proportion, right? And recall in the last chapter 6.3, I think, we talked about, no, not 6, is it 6? Yeah, 6.3, we talk about proportion is an unbiased estimator. That means the population, the sample proportion always target the population proportion. Right? So that's why we can use the sample proportion to estimate the population proportion. Do we have any questions so far?
Well, kind of. I ran into a little bit of a problem. One of the practice problems for, there's not like a page number or anything on these, but it's a practice problem that asks for the best point estimate of a population proportion P. And I used the formula I thought was correct, and then I tried the other formula, and I came up with a like a 1% difference between the two. So I don't know. It's so marginal, but I'm like, I don't know if I'm rounding wrong or exactly how it is. Sorry.
So, okay. Do you know which problem it is? You want to look at this one real quick?
It's let's see here. It wasn't that one. It was actually pretty far back. So I didn't understand how it was like 1% different. So and obviously
if you bring up the problem, we can look at that together.
Okay, sure. That sounds good. I don't know what page it's on, but it's 1, 2, 3, 4, 5 from the end of all of these slides.
Oh, okay. 5.
It's pretty far back there, yeah. It was one of the practice problems.
Okay.
So
it's possible that, okay, let's look. Let's see.
Oh, you know what? Okay, it's a little bit less. Yeah.
So before that,
it looks like slide 29, I think.
29. 29, let's see. 29. This is
oh wait, no, I'm
explanation.
Sorry. It wasn't this one. It was
this one?
Yes, that's the one.
Okay, so point estimate. Here it says in a study of 1,228 random selected medical lawsuits, it was found that this many of them were dropped or dismissed. Conduct a 95 confidence interval for the proportion. Okay. So first of all, the point estimate is the sample proportion, right? In this sample, we have, like, this is your N, right? And this is kind of like your X. Well, if they call it X, I think they call it X. So this represents the sample proportion, like P hat, is equal to just whatever this is. Whatever that is.
Okay, that's what I did. And I got 0.70 or 70%.
So it's just a matter of using the calculation. I don't know, I have a better way to do it. Let's see.
Well, what's interesting is I went on StatCrunch and I put in the numbers to try it on StatCrunch.
Mhm.
And I used the calculation of the upper confidence interval
Mhm.
limit plus the lower confidence divided by 2, and I came out with 71% instead of 70. So I wasn't sure where I went wrong.
Point, isn't it? Yeah, it's like 69, 0.697, something like that.
Yeah, so I rounded to 0.70. Is it
Okay.
2 decimal places or?
I don't know. Here it isn't. It didn't say which, 3 or 2.
Okay.
So you can do either one.
Okay.
I,
Well,
let's.
on
Here, I think they're using the same method.
okay. Okay, so that's the one I should probably just go with.
Yeah.
Okay, I'll ignore the other one then because for some reason it came up 1% different. So I wasn't sure
Mm.
which I should use. The calculation that's on the um, slide. Oh, it doesn't look like it's the next one on yours, but on mine it would have been the next slide. Had like
Okay.
the upper confidence interval limit plus the lower confidence
Oh,
divided
this is
by 2.
okay. So,
Did I
what?
understand that wrong?
Yeah, no. Okay. Why we're doing this? Let me look here. Let's look at a problem. We're
Okay.
talking about this. They are giving you an interval. Say this problem. They said of 71 objects, 70%, 70 confidence interval. Okay, they give you the interval, confidence interval, right? It's 0.58 to 0.81. They give you this and they want you to know what is the point estimate and what is the margin of error E.
Oh, so that's when you
Right.
would use that other.
Because this is p hat minus E, and this is p hat plus E. This is basically how you get these two
Oh,
values, right?
oh, okay. So I misunderstood.
So they're saying, okay, if you want to find p hat, you just add these two numbers up and divide it by 2.
Okay. Oh, I see.
So
Okay.
it's 0.58 plus 0.81 divided by 2. You get the p
Oh,
hat. If you want to find E, then you use the bigger one to subtract the smaller one and divide it by 2.
okay. I think I was confused because above it says point estimate of P. So I saw point estimate and I thought it was like a way to calculate it or something.
No,
But I
it's
see it now that it does say P hat. So,
so yeah, so it's the point estimate. So
okay.
they give you the interval and they want you to find the point estimate, which is the sample proportion and the margin of error.
Okay. Okay. I misunderstood. Thank you for explaining that to me.
Oh, you're welcome. All right. Okay, I think you understand a big proportion of it. So for this one, it's just using what it says. We have a sample size of 1487, and 43% of them said they have a Facebook page. And based on the results, the best point estimate, here we're talking about p hat, which is basically just this 0.43.
Okay. That's what I meant. Great.
Okay, so now definition of a confidence interval. So what is confidence interval? Sometimes a point estimate is not good enough, right? You need a little range, a little interval to say, okay, this interval will contain the real population proportion. That's what a confidence interval is. So, okay, so confidence level, I think it's a bit over. So usually we will be given alpha. So alpha is, these 3 are the most common one, either 0.1 or 0.05 or 0.01. And the confidence interval corresponds to this alpha is 0.9, which is 1 minus alpha. And here, if you alpha is 0.05, then your confidence level is 0.95, similar here. So what does it mean? First of all, this alpha, I don't know if you look at one of the graphs, this alpha is the area in the tail. So if your alpha is 0.1, for example, then the tail in each, the area in each tail will be 0.05, 0.05. So basically the alpha is the area in the tail.
Oh, okay. So it's equally split between each side.
Yes.
Okay. Okay. I I was trying to figure that out, but this makes it so much clearer. Thank you.
And then, so if your alpha is 0.1, then the middle part, this interval, confidence interval, will cover 90% of the whole data, basically 0.9.
Okay.
Okay, so that's the confidence level, which is 1 minus alpha. How confident are you that your interval will include the actual population proportion?
Okay.
So, yeah. So if you look at this slide, it says 95%, the confidence level of 95%, meaning 95% of your samples will include the actual proportion. Say your proportion is 0.5, it's the actual population proportion. And if your confidence level is 95%, that means out of 20 different samples, 19 of the samples will include the actual population proportion. So one of them may not include the population proportion. That's what confidence level means.
Okay.
Okay. All right. Let's see what else. So it's important that you know this is how you interpret the confidence interval. It says we are 95% confident that the interval, this interval, include or contain the population proportion, right? And these two are the wrong ones. Okay. Questions?
No, thank you.
Nope.
Okay. All right. So if you use that crunch or a calculator, you actually don't need to find the z alpha over 2, the critical value. Did any homework problem ask you to find z alpha over 2?
No, not that I could remember.
Okay.
I'm
So,
having an issue with the homework. I emailed you about it just a little while ago, so you might not have got it yet. But every time I try to open it, it just gives me an error with a server and a an ID number, and then a gosh, I can't remember what, a timestamp, and it just says like an error message. So I don't know if anyone else was having that issue or if it's just me, but I haven't been able to open it yet.
I did.
Oh.
Oh, okay.
I was having the same problem, and I had my brother look at my computer. I guess what happened is the Shasta College reformatted their stuff so you can no longer use Google.
Oh.
I'm having to use Firefox in order
okay.
to get
Thank you.
homework
Okay.
stuff.
Okay.
All right.
That's good to know. Thank you.
Yeah, I was like, what did I do?
I know. I like deleted my, all my cookies and everything else. And I was like,
Yep.
what's going on?
Yeah.
Okay.
I've been using Firefox, so I haven't run into that problem yet.
Oh, I see. Yeah, I was running Google, so that makes sense.
Yeah, I was too until my brother said, nope, do Firefox because, yeah, I cleared cache, I did cookies, I did everything.
Yeah.
Wow.
Okay. Thank you.
Yep.
Okay. So since we're using calculator, we skip this part. Margin of error. Do we have problems finding margin of error or just directly finding confidence interval?
I don't know.
Okay. So we can look at one of the problems later. So what is margin of error? Margin of error is the maximum error of the estimate. So like we said earlier, when you have your best point estimate, right? And this minus E, the margin of error is the, the lower bound of your value, and P hat plus E is the upper bound of your confidence interval. So your actual proportion, population proportion, should be in between these two values. And there is a formula here to find the margin of error. So after you find your P hat, which is the point estimate, you find the margin of error, and P hat minus E to P hat plus E will be the confidence interval. So this is the formula we use, right?
Yep.
Okay, so move on. Some notations. So P here is the population proportion. P hat is the sample proportion, which is also the point estimate of the population proportion. N is the net number of sample, your sample size, right? E is margin of error, and Z alpha over 2 is the critical value, which is, if you have a bell curve, and we said alpha is the area in the tail, right? So each tail will be alpha over 2. And what is Z alpha over 2? Is the Z value of over here, basically. Here is Z alpha over 2. Okay. All right. So some requirements you need to have when you estimate a population proportion. You have to have a simple random sample, and the distribution needs to be a binomial distribution. That means first you have a fixed number of trials, then each trial is independent. You have 2 categories. One is success, one is failure, and probability remain the same for each trial. And there are at least 5 successes and at least 5 failures. You don't want to have the sample size to be too small, otherwise it won't be accurate. Requirements. Okay, so I'll kind of talk about this earlier. One problem. Shoot. Okay, so for example, for this problem, you know what? Let's go to a problem in the back. This one. Okay, so you plan to conduct a survey to estimate the percentage of adults who have chickenpox. Find the number of people who must be surveyed.
I don't know if it's me, but all I see is a bunch of lines on your screen.
I see everything fine.
Okay.
Maybe it's me.
I don't think I asked you to find the sample size, so that was a bad example anyway. Okay, so go back to this problem. You can actually use, can you see things well now?
No, my screen is still weird, but she says it's fine, so it might be my computer.
Yeah.
Let me see if I share something else. Is it better now?
Yeah.
Okay.
Oh boy.
Okay. Okay. I just forgot what I wanted to do. Okay, remember. All right. So what is the problem? And the problem says, in the study of this many random selected lawsuits, it was found this many of them were dropped and dismissed. Conduct a 95% confidence interval for the proportion of medical malpractice lawsuits that are dropped or dismissed. So we just found the point estimate, right? The point estimate is the population proportion, which is this divided by that. 856 divided by 1228, you get this. And then you want to find the margin of E. Let's see. You go to proportion stats, one sample. Here is either with data or with summary. In our case, it's with summary. Right, with summary. Okay, number of successes, 856. Number of observations, which is the sample size, 1228. You can see this on StatCrunch, right?
Yeah.
Okay, so confidence interval, confidence level is 95%, so 0.95, and just compute. All right, so you have the upper limit and lower limit. I don't think the standard error is the margin of error. So if you want to find the margin of error, you actually have to use the formula, which is...
you know what I figured out? I think that if you take the z-score and times it by the, where is it? I have no idea what you're talking about. So if you multiply, I'm sorry, not the z-score. If you take the critical
value, yeah.
and then multiply it by that number, it gives you the correct number, but that took me a second.
Oh, that's great. So, all right. So if you want to actually find the margin of error, which you have to use this formula, I can write it down here. So it's E equals Z alpha over 2 times square root of P hat times Q hat divided by N. Let me double check. Divided by what? N, yeah. Okay, so going back here, so in our case, we know P hat, Q hat is 1 minus P hat, right? 97. So, which is, what is that? Okay, so 1 minus 0.697. So 0.303, and Z alpha over 2, which can be found on StatCrunch. So what is your alpha? Your alpha in this case is 0.05, right? So basically alpha over 2 is the Z-score with this area 0.025. So how do you find the Z-score here? You go to StatCrunch. You go to Stat, and I think it's Calculator and Normal. Okay, so with the mean 0, standard deviation 1, because we're just finding the Z-score here, and the area you want to be greater than or equal to, because it's to the right, over here, to the right of that Z-score, and you want the area to be 0.025. So 0.25. Do the calculation. It's 1.95 or 1.96. That is that value, 1.96. And times square root of 0.697 times 0.303 divided by my N is 1228. Do the calculation using your calculator. This will give you the answer, which is, let me see. Where's the square root here? Just a second. 0.697 times 0.303, then divided by 1228. So equals whatever this number times 1.96. So I get 0.0257, some number like that.
Yeah, I got the same.
Okay, so for the Z alpha over 2, you can come over here. I made a chart over here. So if your confidence level is 90%, then your critical value just is 1.645. You don't have to go through the calculation. If it's your alpha is 0.05, then your critical value is 1.96. If your alpha is 0.1, then your critical value is 2.575. So you don't have to go through the calculation. Right? You can just use these values. Anyway. Okay, you find your P, you find your E, then the confidence interval will be between P hat minus E and P hat plus E, right? Which is just whatever 0.303, which is our P hat, minus 0.02, I'll estimate to 6, and 0.303 plus 0.026, whatever these two numbers are, which is, what is it? Minus, that will be 7.9 and 2 plus, that will be 0.329, this interval. Okay, questions?
Nope.
Okay, and then how do you interpret the confidence interval? We are 95% confidence that this interval will include the population proportion. Okay, I think I'm done with this section. Do you have any questions or homework problem you want me to go over? Like any specific number on the homework?
I did until right before the conference. I decided to try it again and realized my mistake.
Okay.
They were looking for percentage, and I was trying to do it the other way. It was I think it was like number 11, I believe.
Okay. So you got that one?
Yeah. It just took me this one. Yeah.
Okay.
I just was looking at it, and I was also trying to use the extra number that they threw in.
Okay. So you just use the same thing. So a lot of them you do not have to find the E.
Yeah.
Right? You can just use, but it's good to know how you got those numbers. Anyway, you can just use either StatCrunch or your TI-83 or 84 to find the values. Okay, you got this one? All right.
Yeah, so it made a lot more sense, and I was like, oh, I'm a dumb person.
No. All right.
I was like, I could have had this one done a while ago if I'd have thought of that one.
Okay, do we have other questions on the homework?
I
don't. No.
Yeah, I don't, because I actually have to switch to Firefox. So I'm okay on that front for now.
All right. Then I'll call it a day. Okay.
Okay.
All right. I'll
Thank
see
you.
you on Wednesday.
Yep.
Welcome. Have a good night.
You too. Thank you.
Mm-hmm.
You too.